Welcome back to another video. Today we will take a look at corollary 2.4.2. So we're going to prove that if A and B are integers such that A is not 0 or B is not 0, then for any integer C, if C divide A and C divide B, then C divide the greatest common divisor of A and B. So let's prove this corollary. Okay, so we're gonna let A and B be integer such that A is not 0 or B is not 0. And I will let C be an integer. So we let C be an integer and assume that C divide A and C divide B. Okay, then we are going to try to prove that C divide the greatest common divisor of A and B. Okay, this seems to be quite obvious, right? When C divide the two numbers, C must divide the greatest common divisor of these two numbers. That means that C is one. If C is one of the factor of A and B, C must divide the greatest common divisor of A and B. Okay, so how can we prove this? So when we have C divide A and divide B, we're gonna have something like this. So by theorem, I gotta remind you this. If you have D divide A and D divide B, what do we have here? We're gonna have for all integer x and y, D divide ax plus by. This is the property in section 3.1, maybe the first theorem of section 2.3. Okay, sorry, it's from section 2.3. Okay, the first theorem of section 2.3, which is 2.3.1, is maybe in the last property in this theorem. Is the theorem about divisibility. So now, if we have C divide A and C divide B, what do we have? So for every integers x and y, so what do we have? C divide ax plus by. Okay, but hang on. C divide the greatest common divisor of A and B, right? So we need to let D be the greatest common divisor of A and B. And try to show that C divide D. Okay, let's use theorem. If you have the greatest common divisor, what do we have again? If you have the greatest common divisor of A and B, then they exist, right? Okay, give me a second. So if you let A and B to be integer such that A is not 0 or B is not 0, then they exist. What does it exist? They exist integers x and y such that the greatest common divisor of A and B is ax plus by. So from this one right here, what do we have? Then by theorem, actually the previous theorem here, theorem 2.4.1, the greatest common divisor of a and b becomes ax plus by for some integers x and y. So we're gonna have, so by theorem 2.4.1, there exists, let's say, s and t, which are integers such that d equal to as plus bt. All right, and since s and t are integers, we can plug in s and t into x and y respectively. So since s and t are integers, so we can have c divide as plus bt. Okay, and this guy right here is d. So what do we have next? We're gonna have c divide d, and d is the greatest common divisor of a and b, so we're gonna have c divide the greatest common divisor of a and b, and we finished this proof. Okay, so if you have common divisors of a and b, that common divisor must divide the greatest common divisor of a and b. And that's it for this video.